Let's start with an important topic, which is OSI model, Open System Interconnection. It is one of the important topic. Why? Because using this reference model, that is OSI model, you will understand how the actual communication happens in the real life. For example, if you are just going to a specific website, how the complete communication is established. This is what we are going to understand over here. So when you talk about the OSI model, which stands for Open System Interconnection Model, it is a set of rules. When you talk about OSI model, when you talk about OSI model, which stands for Open Systems Interconnection, it is a set of rules that explain how the different computer systems communicate over a network. It is a set of rules that will explain you how the different computer systems communicate over a network. We are learning Cisco Certified Network Associate course, CCNA course we are learning. But when you talk about the OSI model, it is not related to a specific Cisco product. If you are using Huawei, HP, or if you are using Fortinet, Alcatel, whatever device you are using, whatever product you are using, all these products will communicate using the same reference model. So this is the logical explanation how the different computer systems communicate over a network. So when you talk about the OSI model, if you can see over here, it is 7 layers. There are 7 layers in the OSI model, and each layer has a specific role in handling data. You can see on the screen all these 7 layers are mentioned, and today session we are going to discuss all these layers one by one. So this OSI model was developed by an organization called International Organization for Standardizations, which is also called as ISO. This OSI model was developed by International Organization for Standardization, ISO. As I told you, this OSI model consists of 7 layers. It consists of 7 layers, and each layer has its specific functions and responsibilities, which we are going to discuss one by one. Considering this layer approach, it will make easier for different devices and technologies to work together. Now, let's say, for example, you have Cisco device, then there is a HP device also in your network. There will be Fortinet device also in your network. So, if each and every device want to talk to each other, each has their own approach of functioning. How they will communicate to each other? That's the question. So, this generic approach helps and make easier for all the devices and technology to work together. So if you have a Cisco device, Cisco switch in your network, then if you have a Fortinet switch in your network, you have a HP router in your network, all these devices will communicate because it is standardized, and this approach is built up on all the devices so that they can work and they can understand each other over a communication channel. So in short, you can say that OSI model provides a clear structure for data transmission and managing the network issues at different layers. And using this OSI model as a reference, you will understand the network system functions. So let's start with the first layer. Everyone is ready, which is physical layer. The physical layer is the first bottom layer in the OSI model. The lowest layer of the OSI reference model is the physical layer. And it is responsible for the actual physical connection. The physical layer, as you can see over here on the PPT, it is actually responsible for the actual physical connection between the devices. Now, if you have a computer, you're connecting the cable, the physical connectivity reference is being described or defined, you can say over here. And on this layer, the data is in the form of bits. The data is in the form of bits. You can see over here 0 and 1. You remember I have told you that whenever the data is transmitted, although we have seen that it is communicating over an IP address, but it actually in the backend it is a bits, the combination of zeros and ones which is communicating. As I told you that the communication devices, whether it is a computer or any networking devices, understand the bits concept of zeros and one. It doesn't understand what is google.com or what is the IP address running behind it. This already we have discussed in our starting lectures. So physical layer is responsible for transmitting these bits from one node to another node. If you have two computers and two computers are connected over a cable, now this physical layer, what it will do, it will transmit your data in the form of bits in the 0 and 1. So the physical on the physical layer, one computer will be transmitting a data to the another computer, and while receiving the layer, on this layer what will happen, the signal received will be converted in the form of zeros and ones. See over here, let's assume over here we have a computer on this side, and this is a sending cable. The cable is connected, and over the cable the data is transmitted in the form of bits, zeros and ones. So this computer, when it will receive the data, it will be receiving in the forms of bits, that is zeros and ones. And once the data is received on the receiving side, then it goes on the second layer, which is nothing but your data link layer, the second layer of the OSI model, which is data link layer. And the common physical layer devices, each and every layer has the devices protocols running. So when we talk about this layer, the common physical layer devices are hubs, repeaters, modems, cables. These all are physical layer devices. Why? Because even on the cables, the data is transmitted in the form of zeros and ones, bits. So let's understand what are the function of this physical layer. Over the physical layer, it provides the synchronization of the bits, which means that the data is transmitted in the form of bits, zeros and one, over the physical layer. On this layer itself, it defines the transmission rate, means how much number of bits per second data is transmitted. You know, when you are downloading or uploading, there is a data transmission given that 4 MB per second or 10 MB per second. So all these functions are being defined on this physical layer. The bit transmission rate, which is nothing but called as bit transmission rate. So how many number of bits per second will be transmitted, that is a bit rate control, is defined on this physical layer. And one more thing, the one more function of the physical layer is transmission mode, which is nothing but physical layer defines how the data flow between the two connected devices. There are two connected devices. It can be a computer to computer, it can be a computer to a router to a switch. So how the data flow will happen between these two connected devices is also defined on the physical layer. Now when you say that how it can be how the data flow is defined, there are different type of modes which we are going to understand: simplex mode, half duplex mode, full duplex mode. These are the different type of modes which we are going to understand in some time. There are different type of modes over here. So the modes can be, simplex mode, half duplex mode, then there is full duplex mode. These are different type of modes. So this all different type of modes, how the data communication is going to happen, what will be the transmission mode, what will be the bit transfer rate, everything will be defined on the physical layer. Is it clear? Any questions over here? Yes guys, any questions over here? Any doubt for the physical layer? Now the second layer that comes in the OSI model is data link layer. So the data link layer, the responsibility of data link layer, you can see on the screen, the frame creation, local network delivery, transmission, transfer frames between net, all this we are going to understand one by one. So the data link layer is responsible for the delivery of the message again, and the main function of this layer is to ensure that whatever data is transferred is error free. If you remember, when we were learning about the functions of the router, at that time we have I have defined one term which was error check. If you remember, I have said error check is done on this. The error check is one of the function of the router, and I have also set CRC frames. So all this functionality, the main function of the layer is to ensure that whatever data is transferred is error free from one node to another over the physical layer. Whenever the data is transmitting, whenever the data is getting transmitted from one node to another node over the physical layer, data transmission, data bit transmission is happening at the physical layer. So whenever that data transmission is happening over a physical layer, it is the responsibility of the data link layer to ensure that whatever data is being transmitted is error free. So error check is done over here. Okay. So what happens when a packet arrives in a network? When the packet arrives in the network from one computer to another computer, whenever the packet arrives in the network, it is the responsibility of the data link layer to transmit it. And for the transmission on the data link layer, it uses MAC addresses. And if you remember, we have discussed that whenever the data is transmitted, it is transmitted in a frames format. Everyone remember that the frame is nothing but a combination of source MAC address, destination MAC address, source IP address, destination IP address. A frame is formed. If you remember, I have shown you that whenever the data is transmitted, it is transmitted in the form of frames. The frames is nothing but the combination of source MAC address, destination MAC address. It will be having source IP, destination IP, source MAC, destination MAC, actual data. You remember everything we have discussed? Yes, guys, be interactive. So, it is a responsibility of a data link layer to transmit the data to the host using the MAC address. Using the MAC address. And the packets which is being transmitted in the data link layer is nothing but called as frames. Now, what happened? Let's say, for example, there are two computers. This is, let's say, there are two computers. This is computer A, and we have computer B. This is computer A and this is computer B, or it can be device A, device B, whatever you can say it. Computer A wants to talk to computer B. We have understood on the physical layer that the data is transmitted, and the data which is transmitted in the form of bits, which is zero, in the form of 0 and 1. And what will the transmission rate is also defined using a physical layer. But whatever is transmitted, whether it is error free or there is error, this is ensured by the data link layer. And whenever the data flow over this data link layer, it is flowing in the form of packets. In physical layer, we have seen that it is zeros and one combination, it is a bit transmission. But when it comes on the upper layer, that is the data link layer, over here the data is transmitted in the form of packets. Packets, it is also referred as frames, and this is nothing but it contains the details of the computer A MAC address, computer B MAC address, what will be the actual data. All this is considered over here in the frames. Now, when this computer A transmit the data to computer B, when this computer A transmit the data to computer B, it is nothing like let's say for example you are transferring one file which is of let's say 1 MB. So it is not like the complete 1 MB will be sent directly within a second to computer B. No, no, no. It is not happening like that. What happens is whenever a computer it transmits the data to computer B, it is divided into small segments. It is divided into small segments. When this is divided, this is nothing but the data transmission rate, data segments, how much data will be transferred per second. This all is taken care by physical layer, and then the frames are formed, the packets are formed, which is the responsibility of data link layer. And now this data is transmitted in the form of packets, which is nothing but small segments. Depending upon the media, what is the media, these packets are divided. Now, what happens once these packets are divided? This data link layer also encapsulates. Encapsulations. Anyone know what is encapsulation? Yes, anyone? What is encapsulation? Welcome, sir. Yeah, I'm good. Yeah, please. Right. How it will be transformed. Okay. If you remember our first lecture on IP addressing, you was there, Ala, in the first lecture, or have you referred the first lecture? Okay, just go and refer that. Over there, I have explained in detail the concept of zeros and ones, how the IP addresses are converted to zeros and ones and transmitted. Because again, to explain that how this IP addresses are converted, or it will take a next 1 hour. So that is not possible. Yeah, you can just refer that first lecture, and you will get an idea how this conversion happens. Yeah. Now, what happened? This data link layer breaks the data into the small segments, and it is sent over the media can be a cable, physical, it can be a UTP cable or fiber, whatever, it can be a media. So this is divided into small segments, and it is not openly sent. This data is not openly sent, it is masked. When I say encapsulation means it is masking. So The data link layer also encapsulates the sender and receiver MAC address. When this computer A sends the data to computer B, it is saying that okay, this is my MAC address, and the data is sent along with this. Now, it is not like the data is sent in the open format. It will mask, it will encapsulate. So the encapsulation also takes place over here in the data link layer. Now the question comes: computer A is sending the data to computer B. I told you that whenever the data is sent, there is a source MAC address and source destination MAC address coming into the role. So, can anyone tell me now this computer A and computer B are connected over the network? Computer A want to send the data to computer B. So, do you know that does this computer A know what is the MAC address or what is the IP address of this computer B? IP address, okay, as a network administrator you can know, but does this computer A know what is the MAC address of computer B? Yes, anyone? Now these two devices are connected over the network. Do computer A know the MAC address of computer B? No, no, we are not going over the switch now for basic. Do computer A know the MAC address of computer B? What about others? I can see Allah is only active in the class. What about others? Yes, guys, please be interactive or you are sleeping. Okay, okay. What about Ahmad, Daniel, Danish, Imran, Sohail? You all are there in the class. Okay. So what is going to happen over here is computer A and computer B are connected, and now let's say for example, the computer A has an IP address 1.1.1.1 and computer B has an IP address 2.2.2.2. The computer A tries to call the IP address 2.2.2.2. What is going to happen over here is com- computer A doesn't know the physical address of computer B. Why the physical address is required, we have already discussed. Why the MAC address is required, we have already discussed. Because the actual communication will happen over the MAC address only. Now the computer A calls the computer B, that is 2.2.2.2. The computer A doesn't know the MAC address. So what it is going to happen over here is whenever the computer A will send a request to computer B on 2.2.2.2, it will ask who has the IP address. What it will ask? Who has the IP address 2.2.2.2. With computer A, when it will send the communication to computer B for the first time, it will say that who has the IP address, and then computer B will reply the destination, that is computer B will reply that 2.2.2.2 is me and this is my MAC address. In this way, computer A will get the MAC address, and this is nothing but called as ARP. This is nothing but called as ARP. ARP stands for Address Resolution Protocol. So if someone asks you that ARP, that is Address Resolution Protocol, works on which layer, you can say that it works on data link layer. Or if someone says that what are the protocols that works on data link layer, so you can say that Address Resolution Protocol is one of the protocol, and there are many other protocols which we are going to discuss. So is it clear like how the communication happens on the data link layer? Now, functions. So what I have to explain, almost everything I have covered. One of the function of data link layer is framing. What is framing? We have discussed just some time before. It provides a way for a sender to transmit the data that are meaningful to the receiver. Then the MAC addressing takes place over here after the frames are created. Once the frame is created, the data link layer adds the physical MAC address of the sender and receiver. The address resolution protocol, the ARP process happens over here. And one more thing, the data rate, what we have seen physical layer, also is ensured over here also. And one important thing of the data link layer is access control. Now, let's say, for example, let's say, for example, this is computer A, this is computer B, then you have multiple computers in your network. When the single communication channel is shared by multiple devices, now this computer A, let's say this is connected, this is connected, this is connected. Somehow, like this connectivity is being established. Now, computer A wants to talk to computer B, and let's say, for example, all the data is flowing from this channel only for computer A, computer B, computer C. So, when a single communication channel is shared by multiple devices over this layer, this determine that which device has a control over the channel at a given time. Now, the computer A is communicating over this channel, so it will this data link layer will ensure that which device has the complete control over this channel. Now, the third layer from the bottom in the OSI layer is network layer. It is very important layer. The network layer is one of the very important layer in the OSI reference model. So the network layer works for the transmission of data from one device or one computer to another located in different places. The actual routing of the data happens over here on the network layer, and the communication over here happens over the IP address. Imran is asking through data link layer computer knows your MAC address. Yes, Imran, that's right because our what I told address resolution protocol happens over here. So over here itself, the computer will determine what is the MAC address of the receiver. You are right. Over here also, the data is transferred in the form of packets, which means that if the data is sent from one node to another node, from one device to another device, first it is broken into small segments, which is nothing but packet. So the first one of the functionality of this network layer is packet creation. As you can see over here, one of the functionality is packet creation. The packets are created over here before it is transmitted. Okay, once the packets are created, then the routing happens. This we are going to discuss what is routing, and then packet assembly. This also we are going to discuss. Now, the first layer of the first function of the network layer, the first function of the network layer is a routing. The first function of the network layer is routing. So over on this layer, on this network layer, the protocols are working. What is protocol? We have discussed what is protocol, right? Yes, please confirm the chat box. Guys, have we discussed what is protocols? What are protocols? But have we discussed? Yes, Danish, Daniel, Sohail, you all are there with me. Right, right, right. It's a set of rules. But I'm not asking what are the protocols. I'm asking like what is protocol? What are the different type of protocols? It's not my question. What is protocol? Sohail says that it is a set of rules. What about you, Danish, Dania? What do you understand by protocol? Okay, so protocol is nothing but a set of rules define how the communication will happen. Now, the first function of the network layer is routing, meaning that if there are multiple paths to reach from one device to another device, the network layer protocol determines which route is suitable from source to destination, and this function is nothing but the routing. Now, let's say, for example, within your network, you have, let's say, this is device A, you have device B, and you have device C. Now, if device A want to reach to device C, there are two paths. From via device B and directly from device A to device C. There are two paths, right? Now, on this layer will decide that if device A wants to reach to device C, what will be the route? What will be the best suitable route for the source to reach the destination? This is one of the function, which is nothing but routing. The function of the network layer is also known as routing. This function, if device A want to reach to device C, which will be the best suitable path to reach to device C from device A, this function is nothing but known as routing, and this happens over here on the network layer. The second function is logical addressing. The second function is logical addressing. To identify each device within the network uniquely, the network layer also defines the IP addressing scheme. So as we have seen that in data link layer, the MAC addresses are placed in the frame. Over here, in the network layer, the IP addresses are placed in the header by the network layer, and the devices identify each other through this unique IP addresses. Is it clear? So the main two functions of the network layer are routing and logical addressing. Any questions for network layer? Imran is asking standard parameter how communication will happen. Imran, will you please ask the question in detail? What do you mean by standard parameter how communication will happen? I didn't understood your question. Yes, Imran. Okay, your doubt is clear. That's good. So the next parameter, so the next layer is transport layer. So basically, the transport layer performs three different functions, which are segmentation, transportation, and reassembly. Let's understand this one by one. The transport layer provides the services or to this upper layer, which is application layer, which we are going to discuss in the coming time. It takes the services from the network layer. What transport layer do is it takes all the services from the below layer, which is network layer, and give it to the upper layer, which is application layer. And what exactly happens over here is the data, whenever it's transmitting in the transport layer, when the data is transmitting in physical layer, when the data is transmitted in the form of bits. In data in layer, when the data is transmitted, it is transmitted in the form of frames. In network layer, when the data is transmitted, it is transmitted in the form of packets. In transport layer, when the data is transmitted, it is transmitted in the form of segments. It is responsible, the transport layer is responsible for end-to-end delivery of the complete message. The transport layer is responsible for end-to-end delivery of the complete message. The transport layer also provides an acknowledgement. It also acknowledge what it acknowledge. It acknowledge whether the data transmission is successful, or what it acknowledge whether data transmission which has happened is successful or retransmission is required. This layer defines whether the data transmission which has happened was successful or the retransmission of the data is required if there is any kind of error. And the protocol that are used on this layer to ensure the successful data communication are two major ones: TCP, UDP. There are others also. There are others. Others are like PPTP, NetBIOS. There are some others. But we are going to understand TCP UDP because these are the major protocols which are used for each and every communication. Now, exactly what happens over here, how the data is transmitted, let's understand that. Everyone is ready? Everyone is there with me? Now, transport layer uses two different protocols, that is TCP and UDP. So, it ensures that whether the data communication which has happened is successfully communicated or the retransmission is required. To ensure that the guaranteed data communication has happened, it uses TCP. There is one protocol known as TCP. So everyone knows about three-way handshake, right? Now what happened? As soon as the data is received on this layer, it will decide that whether the communication has to go through the TCP protocol or the UDP protocol. This transport layer decides whether the data communication is going to happen through a TCP or a UDP. Now, what happened when you talk about TCP? When you talk about TCP, the guaranteed data transmission is possible in TCP, and to ensure that whatever is transmitted is successfully received or there is any corruption and again the retransmission is required, what TCP does is TCP uses three-way handshake mechanism. Three-way handshake mechanism. Now, in TCP, what happened? Three-way handshake takes place where For example, let me take you to the whiteboard to understand this in a better way. Okay. Now, how the three-way handshake happens over here, let me explain you that. What happened? This is computer A. Let's consider this is computer A and this is computer B. Now, computer A wants to talk to computer B. Over here, what is going to happen? As soon as the data is received from the upper layer and it when the data is handled by the transport layer, either the data will be forwarded using a TCP protocol or a UDP protocol. Now we are understanding TCP. So TCP is something where there is a guaranteed that the data transmission will happen, and if there is any kind of error, retransmission will happen. But how it happens, that we are going to understand. That is done something using three-way handshake. Three-way handshake. How three-way handshake happens? As soon as the communication is established, the computer A sends the sync signal to computer B. Sync signal is nothing but a hello packet, you can say. It says that hello, I am computer A. In return, this is sync signal is sent by computer A, the device which starts the communication. As soon as this is received by computer B, the computer B will send sync signal saying hello, I am computer B, and at that same time it will be sending the ACK signal also. It will send the ACK packet also that I have acknowledged your hi. Computer when the computer A has initiated the request saying that hello, I am computer A. Computer B says hello, I am computer B, and at the same time it acknowledges that I have received your packet saying that hello, I am computer A. This is done by computer B, and then the acknowledge signal is sent by computer A saying that yes, I have also acknowledged that whatever you have sent, I have received. This is nothing but a three-way handshake. So now, when the packets come over here from the network layer, it is in the form of segments. So the computer A and computer B, which are transmitting the data, it will the transport layer will decide that whether the communication should happen through the TCP or a UDP protocol. So if it is a TCP protocol, means that the guaranteed communication is required, and if in case there is any kind of error, it need to be retransmitted. So in this scenario, the three-way handshake will happen in this way. The sync signal is sent by the one who is initiating the request. The sync and act signal is sent by the receiver, and then again the sender will send the acknowledgement signal, and in this way three-way handshake is completed. Anyone has any questions over here for three-way handshake, how the three-way handshake is happening? Yes, anyone, any questions? How the three-way handshake happens for everyone, it is clear. Now this is how the TCP communication happens, and how this is how the three-way handshake works. Another one is UDP. Over here there is nothing as such. Whatever is transmitted, it is just received by the receiver, irrespective whether there is any error or whether there is no error. It doesn't matter. Now the question comes: how the transport layer will decide whether the communication should happen over a TCP or a UDP. So the places where you need the proper data. Now let's say for example the communication between an application and a database, the proper data is required, or if you are sending an email, the proper data is required. Over here there is no possibility that you can accept the errors. Now, let's say if you're sending one email and if some part of the email is broken, that is not accepted, right? So, in such scenarios where the data guaranteed is required, in that cases, what will happen? The communication will happen over a TCP, and and the places where the the whatever data you're receiving is not guaranteed. Now, let's say, for example, if there is a voice communication happening, okay, if there is a voice communication happening if there is a voice communication happening and if this three-way handshake comes into the role this three-way handshake comes into the role, don't you think that this three-way handshake takes a time, and if you are saying hello, that hello will not be received. So over here the TCP will not happen, the UDP is the best option. Then thereafter, the best thing which you can see for the UDP is your YouTube. You're watching YouTube, right? So the YouTube, the video streaming. For video streaming, the UDP is the best option. Where the live data is there, if there is any kind of drop or anything, it will not matter. So YouTube, for UDP in video streaming, it happens over the UDP. But when you talk about the guaranteed data communication, then the TCP is the best option. And it is not the administrator or you will decide the communication will happen over a TCP or a UDP. No, the transport layer will ensure that whether the communication should happen over the TCP or over a UDP. Any questions over here? No questions. Let's move on. Now, the another layer of the OSI model is session layer. As the name implies, the session layer in the OSI model is responsible for establishing a connection. It is responsible for establishing a connection. One of the function is establishing a connection, then managing that connection, management of connection, and finally termination of connections. It is not like if the connection is established, it will remain. If it is that is the case, then after some time your link will start choking. So if the communication has been established, okay, the connection over a TCP or UDP has been established. So once it is established, to establishing the connection, session layer is ensuring that the connection is established. Then once the connection is established, managing that connection, and once the communication is finished, then terminating that connection is done by the session layer. And this layer also provides the authentication and security. Over the session layer also, it ensures that there is a proper authentication mechanism and the security of the data transfer is happening over here. And the which are used protocols which are used for the session layer are NetBIOS, PPTP. So the function of the session layer is this layer allows the two devices to establish the connection, use the channel, and terminate a connection once the communication is finished. Any questions? Any doubt? To understand a bit more on this, let's consider a scenario where you can see this over here, right? This one. Let's understand a scenario where user want to send a message through some. messenger application running in the browser. You have, let's say, for example, the Facebook, which you are using through a browser. Okay, so the messenger you're using a Facebook Messenger, for example, and we have not discussed application layer till now. But let's say, for example, the messenger which you're using is an application, right? It is an application. So what happened? Whatever the message this sender will send, whatever the message this sender will send, so this message will be compressed. Okay, it will be encrypted if the application is supporting encryption. Now this sender, this is a sender. Okay, now this sender is using a Facebook application, and he is sending the message over a messenger. Okay, so the very first thing that will happen over here is the data will be compressed before it's sent over the media, and then it is encrypted. The encryption is optional, but it can be encrypted. Now the Facebook Messenger is encrypted, so the encryption will also take place over here, and then it will be converted into the bits, zeros and ones, when it goes to the physical media, so that it can be transmitted and received by the receiver, and then again the receiver will be decrypting that data, and it will be in the readable format. So these all things happen. The communication happens in the session layer in this way. Any questions? Any doubt over here? Now, presentation layer. So the presentation layer is also called as translation layer. The presentation layer is also called as translation layer. It takes the data from the upper layer, that is application layer, and then the data is transmitted as per the required format. The protocol which are used over here are very famous protocols: TLS and SSL. TLS stands for Transport Layer Security, and SSL stands for Secure Sockets Layer. What are these protocols? Everything we are going to discuss in the practicals, but over here just a general overview. So what are the functions of this presentation layer? One is encryption and decryption. Encryption, decryption is one of the function of the presentation layer, and meaning that whatever data is being transmitted, before the transmission the data is encrypted, and then again it is decrypted on the receiver side. Another thing is compression, meaning that the data is reduced in the size before it is transmitted. So this is one of the function, that is compression. And then we'll move to the last layer, which is application layer. So at the very top of the OSI reference model, we find the application layer. Think okay. On the application layer also, by mistake, the presentation layer slide is put over here. No problem. Anyway, I will make it for you over here. Let's say how the application layer works. This is, let's say, application layer. Let's consider for our understanding. Let's say this is some website, and let me make it for you something. So whatever the data is produced over the network, it is taken care by the application layer. There are many protocols for the application layer. It can be HTTP, HTTPS, SMTP, FTP, DNS, and there are many. So what are the main functions of the application layer? See, whenever you are trying to access some website through a browser, that is possible through application layer. File transfer you're doing, that is something which is taken care by the application layer. Mail services, directory, whatever you're doing, everything is taken care by the application layer. So you, as a user, you open the browser, and what you do is you will say that http colon www.google.com or https colon. So you says that you request the content in the required format. You says to the website that I want your web page, and for the web page you say to the website that https, you request the content in the required format. Or if you want to download some content over a ftp, you says that ftp colon the ip address or the domain name, right? So what you're doing is when you say that https colon the domain name, or you say that https colon the domain name, you are requesting the content from the website in the required format, and then the website replies back to you the requested content. This is nothing but the application layer, the work. This is how the application layer works. Now, now, whatever we have discussed whatever we have discussed till now, let's understand this, how this happens in a real world environment. We have discussed the from the starting physical layer, we understood data link layer, we understood network layer, then we have understood transport layer, session layer, presentation layer, application layer. We will be understanding now actually how the communication will happen. Everyone is ready? Please confirm in the chat box if everyone is ready. So Daniel, you are back. I think you was not there in between. Okay. Now let's say there are two users. Let's understand in the real life, in the real life, how the OSI layer will work, how it will take place. And let's say these are two users or a user device. You can say this is user A using his computer or a laptop, okay, and this is user B. Now this user A is sitting somewhere in the world and user B is sitting somewhere in the world. They are connected over an internet, okay. User A want to interact, user A want to interact with user B, means user A want to talk to user B via email. Okay, user A want to talk to user B via email. The email can be, it can be a Gmail, Outlook, Yahoo, Gmail, Hotmail. It can be any email. Okay, it can be any email medium. So user A want to interact with the email via email application like Yahoo, Gmail, and what happens over here is user A writes an email. User A writes an email to user B that need to be sent. Okay, so when the user A want to write an email, what it will do, he will be opening the browser. He will be going to that specific Yahoo Mail, Gmail, whatever it can be. So that is nothing but it is happening over an application layer. Okay, so it opens the site and it's request a content over HTTPS, asking that I want to open the specific site. He logs in into that Yahoo or Gmail sites, and then he composes an email and sends an email. Now user A has sent an email to user B. Application layer job is done. Now mail application, when the user A has created an email, the mail application prepares and user A clicks on send button. As soon as it clicks on send button, the mail application, it can be Yahoo, Gmail, Hotmail, whatever it is, it will start to prepare. Mail application will start to prepare for data transmission. It will start to prepare for data transmission. So when it is starting for data transmission, what will happen? It will encrypt your data. It will encrypt your data and format it properly. Okay, formatting is also done. What it will do? It will encrypt your data, meaning that whatever data is transmitting, no one else can see. It will encrypt your data. And I don't need to explain encryption because it's a very common term everywhere. You will find on even your WhatsApp you will find encryption. Encryption is nothing but converting the data into non-readable human format. It will encrypt the data, and the formatting will be done before it is transmitted. Once the presentation layer job is done over here, what happens? The mail application start to prepare for data transmission, which meaning that encryption and formatting is done. Once this is done, from the user computer to the mail application, this job is done. Now the connection is established. There is a connection established. Connection established between sender and receiver over the internet. The connection will be established now between the sender and receiver over an internet, because these users are connected over an internet. Once the connection is established, the session layer job is done. The connection established, session layer job is done. Now this email which was composed can be of 2 MB, 4 MB, 10 MB. It can be of any size. This 10 MB or 2 MB or 4 MB cannot be transmitted at once. I have told you. So what is going to happen over here is email data. Email data is broken into smaller segments. Broken into smaller segments. And now there is one problem. Let's say, for example, 1 MB data was there. It was broken into 10 pieces. It was broken into 10 pieces. Now, when this email data was broken into 10 pieces, there is a possibility now that piece 1 was having the data of first line, piece 2 was having the data of second line. So there is a possibility that when the receiver will receive it, there's a possibility that the line 1 will be received, then line 10 will be received, then line 4 will be received. There's a possibility, right? Because the receiver will also receive the data into the segments only. So what happens over here? Once the data is broken into smaller segments, it adds sequence number. The sequence number is added 1, 2, 3, 4, 5, 6. So what happens when the sender sends the data? It is broken into smaller segments into the transport layer, and now for each broken segment, three-way handshake is going to happen. So when that three-way handshake happens, the sync and X signal is sent. At the same time, it checks for the sequence number also. I have received sequence number 1, then the next sequence should be sequence number 2. If it is not sequence number 2, it is some other sequence, it will drop it. In this way, the proper sequence is whatever the sequence is sent, the proper sequence is received at the receiver side. And of course, the error check is performed. If it is error free, then it will give it to the lower layer. Why the error check is done? We have already discussed, so that we can have the error free data, the proper reliable data we can have it. Once this is completed, once it is broken into smaller segments, the sequence number is added, it is given to the lower layer, that is network layer. Now the network layer decide that if user A want to reach to user B over an internet, which is the best route, which is the best route to reach. There will be hundred of routes over an internet to reach to user B, but the network layer will decide which is the best route to transfer this data, that the communication will be happen as soon as possible. So the best route is decided. Once this best route is decided, then once the best route is decided, it will give it to the lower layer, which is data link layer. Okay, at data link layer, this data packets are encapsulated into frames. Encapsulated means it is masked, and in the frame the MAC address of the sender is added. And finally, what will happen, that at the seventh layer, that is a physical layer, at the physical layer, the frames are transmitted. The frames are transmitted at physical layer. Frames are transmitted in the form of electrical signal, electrical, or you can say optical signal over a physical network. This is how the communication happens at the center side. Now, once this everything is completed and the data is received at the receiver side, which is user B, you know what will happen over here? The process will reverse. After the email reaches the receiver at the user B, the process will reverse, and now this signal will be received in the zeros. The data will be received in zeros and one. Then it will decapsulate. It will, after decapsulation, over here the best route will not be there because already the data is received. Na? So this process will not come into the role. Directly, the encryption was done over here, right? The encrypted data will be decrypted. The email content will be decrypted. Whatever the data is received in the form of zeros and ones and it is encrypted data, that data will be decrypted. The data will be decrypted. And once it is decrypted, the email will be shown to person B, the user B, that is the email client. Is it clear? Any question, any doubt over here? Yes, guys, any questions, any doubts? Okay, let's move ahead. Now, why this OSI model is important? Although we have discussed in the beginning itself, but before I conclude, let me tell you that it provides the clear structure that how the data will move in the network. And as the OSI model consists of 7 layers, each layer has a specific role, and it helps you to understand and identify that how exactly the data communication is going to happen at different layers. We have discussed of this OSI layer for around 1.5 hours, but let me tell you one thing. In the modern era, the OSI model is not preferred. The data communication which is happening, which we have seen over here in the OSI model, it is not preferred, but still it is very helpful to understand one very powerful model, which is TCP IP model. And actually, the communication which happens through the TCP IP model. What is TCP IP model? This is like a 30 minutes topic. 30 to 45 minutes I will take for this topic, and we can discuss and finish it off. So, any questions, any doubts? If there is nothing, it's the right time to stop over here. Thank you. Bye bye. Take care. See you.